This is very laggy, but we can optimize this, and we can go down to this, and this is much faster, right? So in my procedural generation tool, I'm doing a lot of optimization tricks, and I want to show a few of them to you. But first, let's start with the naive approach. So this is the laggy approach that you've seen previously. So here, for each tree object, we're going to create a mono behavior. So we're going to assign a component. And so each tree is going to be responsible for the computation of its position. So the code is pretty straightforward, as you can see here. And so each tree is responsible for its own behavior. And in terms of performance, it's not very good. As you can see, we have 62 millisecond compute time. The usual approach on the other end is what most people are doing. It's gonna make the memory much more happy, because instead of spreading the memory and creating a lot of mono behavior and spreading the data on the RAM, it's gonna have the data much more in a contiguous way. And so just by putting everything inside an array, we're going to see performance benefits. So here we have a manager that's going to handle all the positions and all the transforms. And so inside this tight loop, everything is going to be processed, and the performance is going to be much better than what we had before already. Here the performance is much better. We are at 47 milliseconds for the processing of all the positions, but we can still do better. I'm sure you've heard of dots and bursts when talking about Unity, so let's do some burst jobs optimizations, right? Let's implement the burst implementation. So what we had before was a regular loop, and now we're gonna implement basically the same thing, but as a burst job. So Unity, when implemented this way, is gonna parallelize the execution, but it's also gonna vectorize, which means that it's gonna use processor-specific optimizations to optimize all the processing for each execution. But let's jump right away into more optimizations, because currently the memory is badly handled. We have to copy the memory from the CPU to the GPU every time and every frame. And so we want to avoid this. We want to share the memory between the CPU and the GPU. And a way to do that is to use the graphics API. So now we are no longer using game objects to represent our objects. We are simply using the graphics API to draw each one of them. And this is the most powerful optimization you can do when you don't actually need game objects. Performance is already much better now. We are running at 60 FPS, but it's still a bit heavy for what it is. And we can see that the physics are taking like half of the processing time. So let's address this. And thankfully, Unity has an API to do that. There's always an API to improve that. So we can use the raycast command, and what this basically does is that you can batch a bunch of raycast or even spherecast or any physics command. You batch them all and you execute them in a batch, and this is much optimized than running them one by one. And with that, we are gonna get much better performance. And as we can see now, we are running at 120 FPS, and most of the processing is actually required here. The physics is not taking much of the time, so it looks good. Hopefully you can use some of the techniques here for your own projects, but those techniques are the techniques I'm using in OctoShaper. This is a procedural generation tool that I'm currently creating. And if you enjoyed the video, there's a link in the description to check it out.